Hello guys, this is Paul McWhorter with TalkTechBoy.com, and we're here today with episode number 103 in our incredible new tutorial series where you are unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee, poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Kepler kit for Raspberry Pi Pico W. Now, hopefully most of you guys already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what this is it's an extension of the work that we've been doing in the last dozen or so lessons where we are learning about the Raspberry Pi Pico PIO state machines. So we've done what, like a dozen lessons on that, and we have gotten pretty proficient on the state machines all the way up to last week creating a custom library that controls servo position using only the state machine. So we've gotten where we're pretty good at programming the state machines. But there's one capability on the state machines that is very, very important, and I haven't taught you yet, and that is how to use interrupts, IRQs, interrupts. And what I'm going to teach you today is how you can trigger an interrupt inside of a state machine, and then that interrupt that is triggered can be used in either the main Python program or in the program for that same state machine, or it can be used by another state machine. So you can have a state machine that is triggering interrupts, and then those can be used sort of anywhere else that you want, from the main Python program to other state machines on that PIO block. So that's what I'm going to be teaching you. Does that sound good? I hope it does. So let's jump in and let me kind of give you a framework of what we're going to be doing today. So I think I could do that if I came over here to this live view, and if I got out of your way. This is what we are going to build. Now, today, in today's programs that I'm going to be writing, we're only going to be using the green button and the green LED. Okay, only the green button and the green LED. And what I'm going to do is I'm going to set up an interrupt watch on this green LED, and then when the interrupt is set or triggered by the button being pressed, then there is going to be an interrupt handler in the main Python program that will then turn this green LED on. And of course, as you could imagine, it's going to be a toggle. So press release once, the LED comes on, press release again, the LED goes off. But the interrupt is created on a state machine and is utilized in the main Python program, You know, I could sit here all day trying to get these LEDs aligned perfectly. I could just stay here all day, because no matter what I do, they're never going to be quite good enough. But I will spare you what my natural instinct is to get better alignment on the LED. I will spare you, and I will continue on with this lesson. Okay, so we're going to be using this and this. Then the second program we're going to do is we're going to have one state machine that's going to be watching the button and generating the interrupt, and a second state machine that's going to be taking that interrupt and then controlling the LED. And then your homework, I bet you can see it coming. You're going to have 3 buttons, and you're going to have 3 LEDs, and you're going to control the LED from the buttons with everything being done on the state machines. Nothing can be done in Python. You have to do everything on the state machine, except for, of course, you can activate the state machine in Python, which you've got to do. But beyond that, all the work is going to be done on the state machine. Now, why am I so explicit in those instructions? Because it's very challenging to program on the state machine because you've got a limited set of commands to choose from, and you have a limited number of lines of code. And so to do something on the state machine, it requires you to activate new parts of your brain, new creativity, new problem solving, new thinking outside the box. But what is our tendency? We go down to the state machine. First little challenge that we run into, boom, we hop back up to Python, and then we start doing the hard work in Python. And then pretty soon it's like, well, why are you even bothering doing the state machine? So that's why I want you to really get adept at thinking about creative solutions. Okay, that sounds good. Now what we need to do is go ahead and you guys wire it up, even though we're just using the green and the green, since it's going to be on the homework assignment. If I were you, I would go ahead and kind of hook the whole thing up. So let's see if I can come over here and get that view. So what I will need you to do is I will need you to go to the most excellent www.toptechboy.com, and then there, if you will search on something as simple as Raspberry Pi Pico state machine IRQ interrupts, you can use this happy little search tool or the little Google search bar. You'll come here and then you will get this schematic. If you click on the schematic, it will make it a little bigger and easier to read. You can see 3 buttons, 3 LEDs, 3 1000 ohm resistors. And the one thing, I mean, you can copy this, I mean, you can easily enough see it, but I can't help but just give you a little help. We are using GPIO pins 11, 12, and 13. 11, 12, and 13 on the buttons. And then down here, we are using GPIO 20, 20, 19, and 18. 1000 ohm resistors. But the one thing that really matters is notice that on these buttons we are connecting to the power rail, and because we are connecting to the power rail, that means that when we activate these pins, we've got to activate the pull down resistor. Now, why a pull down resistor? Because with the pull down resistors, the nominal position is 0 on the button, and then when you press it, it gets a 1. And for these cases where you've got a lot of limitations in what you can program, it's just the logic of the program flows better if 1 is the button down and 0 is the button up. Okay, so you guys can go ahead and get that connected up, and then you know what? I think that we are ready to start coding. Can you believe that? So the first program, what do I want to do? I want to fire off the interrupt on the state machine. And then in the Python program, I want to have an interrupt handler that does something, a Python function based on that interrupt that was generated in the state machine. So let's see if we can do that. First of all, we will need to import RP2, our state machine library. Then from machine, we are going to import pin, as we almost always need to do. And then for good measure, let's import time, because you never know when you might need to put a little delay in here. Now I'm going to go ahead and give notice that we've got incoming machine code with an RP2.asm_PIO. And because this is going to be an input looking at those pins, we really don't have to set any parameters up here. We don't have to like initialize our pins or anything. Okay, now what is very useful is for us to come over here and as always put in our wrap target like that. Okay, now what do I want to do? I want to wait. So what is this program going to do? It's going to get to this line of code and it is going to wait. It is going to wait until it sees a 0. It is going to wait till it sees a 1 on a pin. And then which pin? It is going to be pin 0. Now that pin 0 is relative. That pin 0 is relative to the pins that you set up. And so if your base pin is 14 and then you say pin 0 here, if your base pin is 14 and you say 0 here, then what is going to happen? That is going to be that pin that was your base pin. Okay, so this is kind of like relative, I guess I would say. Okay, now we are going to, let me see here. Give me just a second. You guys just give me just a second. I need to do one minor adjustment here. Okay, I think I can come back here and just having to do a little bit of Windows management. Now I think you can see that okay. So we're going to wait at this line of code until the state machine sees a 1 on pin 0. Now for us, pin 0, I believe, is going to be pin, it's going to be pin 11, I think. It's going to be that first one, pin 11. So it's like pin 11, 12, 13. Pin 11, 12, 13. And yes, that one is the one all the way over on pin 11. Okay, so that will make sense in a minute. So it's watching pin 11 for a 1 signal, and then when it sees a 1 signal on pin 11, then it releases. Okay, it releases. So this isn't the interrupt. This is just waiting for a signal. All right. Now you know that to debounce the switch, we kind of want to put some delays in here. And so I'm going to go ahead and see if I can afford to put like no op 31, no op 31. Get our alignment nice here. Okay. No op. Okay, so that's 1, 2, 3. Let's do one more. No op 31, like that. Okay, so that'll give a little time for the switch to debounce there. So when it goes down, I don't want it to be triggering over and over. Okay, so now what do we want to do? We want to officially trigger our interrupt. So I'm going to say trigger the IRQ. All right. Now, what do I want it to do? I want it to block. And what that means is now I'm going to wait at this line of code until somebody, somewhere, somehow, some way turns that interrupt off. So it's going to sit here until the interrupt is cleared. What does that mean? When we're writing the other part of the code, whether it's on Python or in the state machine, we got to make sure that that interrupt is cleared, or this is going to sit here forever. Now, I'll give you a hint. When the Python program handles the interrupt, that interrupt handler automatically, without us doing anything, clears the interrupt. Like, got it, I'm handling it, and it resets it, even though you don't see it. But if you're working down in the other state machine, you have to explicitly clear the interrupt, okay? Now, the question is, we have how many interrupts? We have 8. Well, I am going to trigger interrupt 0. Now, this is something very important that I should explain. Okay, we have 2 PIO blocks, right? 2 PIO blocks. This PIO block has 4 state machines. This PIO block has 4 state machines. This PIO block has 8 interrupts, and this PIO block has 8 interrupts. Now, the state machines on this PIO can all sort of share those interrupts. Any state machine can see the other state machine interrupt because those 8 interrupts are common on this state machine. And then this down here, this PIO block, all those state machines can access those same 8 interrupts. So those 8 interrupts are shared between these state machines. These 8 interrupts are shared between these state machines, but these state machines can't see these interrupts, and these state machines can't see these interrupts. Okay, does that make sense? But now, the main Python program. Now these can say, hey, I'm throwing interrupt 0 at you, gotcha. Hey, I'm using interrupt 7, gotcha. Hey, I'm using interrupt 3, gotcha. You see, they can use any of those interrupts. but the only interrupt that you can really see in the main Python program is interrupt 0. And then you just tell it which state machine it's on, but then it only sees interrupt 0. So if we're going to be triggering an interrupt handler in Python, we better use the interrupt 0. Now you can use it on any of the 4 state machines or any of the 4 state machines, but wherever you use it, you have to use interrupt 0. Does that make sense? Okay, hope it does. So now I am using interrupt 0, and then I'm going to sit here until somebody clears the interrupt. Okay, I'm going to sit here till somebody clears the interrupt. Now what do I need to do? I need to now wait. And what am I going to wait for? I'm going to wait for the button to be released. So how did I get here? The button was pressed. Now I'm going to hold here till the button is released. Otherwise, if you just hold the button down, it can kind of just keep looping and looping and looping. And so you've got to make sure that it doesn't just go into that constant looping. And so you press it, and then you release it. So what am I going to wait for now? I'm going to wait for on that pin to see a logic 0. That means the pin has been released because we're using a pull down resistor. And then what? I'm looking at pin, and then what? I'm looking for a logic 0 and on pin 0, which would be whatever my base pin is, which I believe here is going to be pin 11. Okay, now let's go ahead because we can afford it. And let's take these no ops to give us a little more timing so we don't get any noise on the release, right? We release it and maybe we get some bounce on the release. And then what we need to do is just wrap like that, okay? I think that looks pretty good. So that is the state machine part of it, but we've got to go ahead and instantiate it. So let's go ahead and set up our button pin, okay? Our button pin is going to be equal to pin the method, and then what did we say? It's going to be pin 11, okay? And then that is a pin dot in, and then what? Pin dot pull, what did we say? Pull down. So we've activated the pull down resistor, and so that's good. Now let's instantiate our state machine. So I'm going to say state machine button. So I'm naming my state machine button. In the past, we would name it SM0, SM1, SM2, but here I want it to be a little more descriptive. So I'll say state machine SM button, and that is going to be equal to RP2 dot state machine. What state machine are we going to use? We're going to use state machine 0. And then what are we going to call? What function are we going to call? And did I put that in or did I skip that? This is a horrible mistake. What I didn't do is I didn't put my function definition. I hope you guys were yelling at me. It's button IRQ, like that. Does not count as an error if you find it before you run it. So I'm defining there the function, and I'm sure you guys understood that needed to be done. And then down here, what do? I'm using state machine 0. What is my function? It is button IRQ. And then we like to go slow, so we're going to go about as slow as we can at 2000 hertz. All right, and then what else do we have here? I need to set my in base, and what is that equal to? That is equal to button pin, okay, button pin like that. Frequency button IRQ. Okay, so now how does it know? That is pin 11? Well, I'm initializing the pin here, and then what am I passing in as the base pin is button pin, and button pin knows that it is pin 11. So that's just kind of a nice way to do it, I think. All right, now we are done with we are actually completely done with the state machine part of it. Now we've got to come back to the Python part of it. And so I need to go ahead and set up my LED pin. All right. And that LED pin is just going to be equal to pin. What pin? It was pin 18, and that was a pin dot out. Pin 18 from the schematic. You know, from the schematic, you're going to be able to see that it is pin 18, like it's 18, 19, 20, and 18. It's 18, 19, 20, and 18 comes over to the green LED. I counted going the wrong way the first time. Okay, so that is going to be an output pin, all right? So we've got that. Now what do we have to do in Python? I have to define a button handler, okay? And where is the button handler? What is it going to be looking at? It is going to be looking at a state machine. I just got to put something in there, so I'll just say SM. In fact, okay, I'm not sure why we got to put SM, but I think something has to go there. I thought that that might be the name of the state machine, but it's not. So I'm not exactly sure precisely of that syntax. But what I do know is, what do we want to do if the button is pressed? Well, LED pin, that is our LED pin. We want its value to do what? Not LED underscore pin dot value. I don't know if there's a toggle command. But this is a way to do it. And we got to have an open close there. So the LED pin value is not the LED pin value. All right. And so you're basically toggling. It's a way to toggle. Okay. So that's all we've really got to do in there, I think. Now what we have to do is we have to set the IRQ. We have to set the interrupt request. And guys, we've done interrupts, just Python interrupts in earlier lessons, so you should be familiar with that. And just what's different here is I have to tell it which state machine the interrupt is coming from. It's the state machine underscore button dot what? IRQ. And then what do I want? I want button handler. All right. Now, this is the state machine that I will be looking for an interrupt from. I can specify the state machine. I can't specify the number of the interrupt because it's going to look for 0. But never fear, 0 is the interrupt that we set up in the state machine code. So this is the state machine that it will be looking for. And when it sees that interrupt on interrupt 0, when it sees that trigger, it's going to run up here and do what? It's going to run button handler, and then button handler is here, and it is going to trigger the LED. Now, somebody tell me the one thing that we still need to do that's very easy to forget and very hard to debug. We need to take that and we need to we need to make it active like that, okay? Now, I don't even think that we need to put a while loop in here. Okay, I don't think we need to put a while loop in here, but I might have had some mighty big typos in here. So let's run this thing and see what happens. So all eyes here. What is that? Line 5, already on line 5, it doesn't like it. What did I do on line 5? Okay, at rp2.asm underscore PIO. And that does not need a colon. Okay, that does not need a colon. That one scared me a little bit, to be honest, but now we are running. Okay, it looked like it ran. Now, I'm so frightened. I am so frightened. I will come over here and boom, did you see that? Now watch this. Off, on. Look, toggle. Okay, so when I press this button, it's going to generate an interrupt, and then Python is going to act on that interrupt, okay? And you see, as I'm going, I am very nicely debounced, okay? Boom, state machine IRQ sending an interrupt to Python that is then processing the interrupt, is then handling the interrupt. How cool is that? Okay, well, the only thing that would be cooler would be if my LEDs were a little bit more perfectly lined up. There. That is almost perfect. Well, almost. Okay. Anyway, we will move on. We will move on. All right. So now that is what we did, and that is just pretty darn cool. So now what do I want to do? I want to now go in, and instead of doing, all right, let's see. Let's come back over to our code. All right. Now, what all this we're going to take out, okay, because we can't do anything in Python. What do we have to do? We have to do it on state machines. So we're going to come up here and then modify this code to use a state machine. So still we're going to import, okay, and now we're going to define button IRQ. And what are we going to do? We're going to wrap target. We're going to wait for a 1 on pin 0. We're going to put some no ops in there. And then we are going to wait for the button to be pressed. And then we are going to wait for okay, so what we're going to do is we are going to wait for the button to be pressed. When the button is pressed, then we're going to stall here for a little while. Then we are going to set IRQ 0, and then we are going to sit here and wait until somebody clears the IRQ. And then when someone clears the IRQ, we are then going to wait for the button to be released. And then when the button is released, we're going to pause a little while. We're going to pause a little while to make sure that we don't get a bounce on the release, and then we are going to wrap. Okay, so we just kind of went over again what we had already done. Now, what I need to do is I need to create another state machine. Okay, we'll get down to that other stuff in a minute, but I need to create another state machine at rp2.asm_PIO. Okay, this time we are going to out init, and that is going to be equal to rp2.pio.out_low. Okay, now I have 3 pins. I have 3 pins. I have 3 pins, but in today's lesson we're only using one of them, so I just have to out init, and that will out init the base pin, right? So I don't have to put anything else there, and we are doing an out init like that. Okay, now what I'm going to do is I'm going to set x to 0b and then 1, 2, 3, 4, 5. So I'm going to set my X register to all zeros. All right, so I'm going to initialize my X register. Now I am going to wrap target so I have a place to land. And then now, so this has 0 in the register, right? 0 in the register. Now what I'm going to do is I'm going to wait, and I'm going to wait for a logic 1. But I'm not going to wait on a pin, I'm going to wait on an IRQ. Which IRQ? 0. Okay, so what does this say? I'm going to wait for the IRQ, the interrupt number 0, to go to 1, which means it has been triggered. So it's triggered up above, so I wait here until it's triggered, and once it's triggered, then I can go to the next step. Now I want to move. Okay, what do I want to move? I want to move X to invert X. Okay? Now what does that do? That all of a sudden what was 0, 0, 0, 0, now that's going to become what? 1, 1, 1, 1. So do you see why I do this? Why am I doing this? What is the hard thing to do in a state machine? The toggle. Okay, the toggle. But I'm taking X and I'm inverting it and putting it back into X. So now what is X? X now is 1, 1, 1, 1. Now, since I'm only using 1 bit, I could probably have just said 0, B, 0, and then invert that. But I left more space so that we could expand it later. Okay, so now that is on X. But do we want it on X? No. Where do we want it? We want it on the pins X, like that. Okay, now the LED should come on. But what do we better remember to do here? We better remember, we darn well better remember to what? Clear that that interrupt request, clear that interrupt. Which interrupt? The 0 interrupt. So this is which interrupt? The 0. What do I want to do? I want to clear it. And then that releases this program to start running again. Okay, so I do the IRQ clear, 0. Now what am I ready to do? I am ready to wrap this baby up. Okay, so that is wrapped up. Okay, so we've got that ASM PIO out init. I'm just looking this over. This looks pretty good. So here I have instantiated the button pin. Okay, now I have defined the LED pin. I'm going to go ahead before I forget it, and I'm going to say the SM, and then what I'm going to call this state machine is LED, and I'm going to not forget to dot active 1, like that. This state machine active is kind of like using the OLED, and it's the OLED.display. You write the whole program and you can't figure out why it doesn't work. Well, you've left out one of those lines. Okay, but now we're going to come back up here and we've got the LED defined and activated, but now what I need to do is instantiate the state machine. So rp2.state machine, and that is going to be state machine 1. And then what do I want to do on state machine 1? I want to run, and did I do that again? Darn it, I did the same thing again up here on this one. Didn't I do the same thing? I put the colon there, and then I did not do the define LED underscore control as I should have. Can you believe I made the same mistake on both of those? Okay, but doesn't count if you catch it before you run the program. So now what do I want to run here? What do I want to run? I want to run LED underscore control, and then we like to use a frequency equal to 1000. And then what do we want to do? We want to set up our out base. Our out base is equal to LED underscore pin. Okay, so how will it know what pin? Well, because LED pin is here, and it knows there it has been defined as pin 18. Okay, now I'm just looking. I'm so scared. I'm so scared. LED pin, and then this I didn't give it a name, so I made a little mistake here too. So I need to give it. This is SM underscore LED is equal to SM LED is equal to that, and then I activate both of those. Okay, now I am wondering, I'm going to go ahead and turn that off from the old program. How many mistakes did I make? Okay, let's go ahead and run this and see what we did. RSP, oh, RSP is RP2, I think. Okay, I did not do well on that, did I? RSP should be RP2. Now that one counts. That one's on me because I ran it and there was an error there. Okay, I'm so afraid to press the button. Okay, let's go over. Let's get a bigger view and let's see what happens. Boom! You see that? Boom! Look at that. State machine only. Interrupt handler on another state machine, making the LED blink on, blink off. I think I would like the green LED. Boom! Look at that. Okay, so that is pretty cool, right? I think this has been a pretty good lesson where you have learned how to do the interrupts and how to handle those interrupts in Python or how to handle those interrupts in another state machine. So this is what your homework assignment is. Give me just a second. Your homework assignment, as you could probably imagine, is to be able to do that, 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 be able to do that. We can go 1, 2, 3, 3, 2, 1. Okay, on and off, done how? Only on the state machine. Okay, so when I see your code, that code had better not have anything but these state machine definitions, right? It better have nothing. It better have nothing but these state machines. I think this is the best one. Nothing but these state machine definitions. It shouldn't do anything else other than that, okay? All right, guys. Now, I'll tell you, you're going to think that it's really easy, but I'm giving you this homework assignment because there might be a few roadblocks along the way of how you're going to have to figure out how to get this whole thing working nicely like I just showed you, okay? There might be a few tricks, and so you can't give up. I've shown you everything that you need in order to make this program work. I've shown you everything that you need in order to make this work, but you just got to look in your toolkit and you got to pull those tools out and use them, and you've got to do it back. You got to do it without running home to Mama Python. Okay, you can't run home to Mama Python. You got to do it like big boys and girls in the state machine. Okay, guys, I hope you're enjoying taking this class as much as I am making it. It's at this point that I always want to give a shout out to you guys who are standing with me on Patreon. What you got to understand is when we are going into this depth of material where we're doing interrupts on state machines, most people have dropped out, okay? And so when I do these really advanced in-depth lessons, I get thousands of views and not hundreds of thousands or millions. And so the only way that I can do these in-depth lessons is with the support from you Patreons. And so I want to give you a big thank you for enabling me to really do this more advanced work. You can also help the channel by giving me a thumbs up on the video and leaving a comment down below. If you haven't already, make sure that you subscribe to the channel. When you do, ring that bell so that you'll get notifications when future lessons drop. And most importantly, share this video with other people because the world needs more people working on state machines and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.